Now let us discuss another question which came in the year of 2016 in the GATE Excel biochemistry, and the question number is question number 17. So this came from the metabolism topic, where this is specifically going to the enzyme kinetics. Now the question states kinetic parameters for the enzyme fumarase with three different substrates are given below. Substrate fluorofumarate, fumarate, fluorofumarate. Okay, so these are three substrates, and this Km and Kcat value is given. So what is Km and what is Kcat value, that we will be discussing first in the next slide. So what is the question? The specificity of fumarase for the substrates decreases in the order. So they are asking about something called specificity of an enzyme. This fumarase is an enzyme here, and these are three substrates. So in the decreasing order, what will be the specificity of the substrates of this enzyme towards this substrate? Okay, so now first we need to go through what is Km, what is Kcat, and what is specificity of an enzyme. So as we know that the enzyme kinetics is linked with the famous Michaelis-Menten equation. So let us first discuss about Michaelis-Menten equation in greater depth. So Michaelis-Menten equation gives a relation between the rate of or the velocity of the reaction, the velocity or the rate at which the substrate is getting converted into its product, where this here this P is mentioning the product and S is the substrate. So this is given by the relation is given by this Michaelis-Menten equation. So what it states is V naught. V naught is the initial reaction velocity, okay, which is linear to the substrate concentration, as you can see in this graph. That's why initially when the substrate concentration is higher and the rate is the just proceeding, so initially, and the product concentration is minimal there, so the initial rate will be dependent directly proportional to the substrate concentration, and it is following a first order kinetics. But when you see that this is reaching at some point a saturation, so in the later phase when it is reaching the saturation, the rate or the velocity is no longer dependent on the substrate, and this follows a zero order kinetics. Now, if we look into the Michaelis-Menten equation, it is V naught equal to V max. V max is the maximum velocity that can be attained by this enzyme while converting the maximum rate at which this enzyme is converting this substrate to this corresponding product is the Vmax, and this S is the substrate concentration divided by it is the Km plus the substrate concentration. So what is Km? Km is the Km can be defined as the substrate concentration at which the velocity or the rate of the maximum velocity of the enzyme kinetics, that is Vmax, is divided by 2. Means half the velocity of the maximum velocity at that point, what is the concentration of the substrate, that is defined by Km. And in the form of kinetic parameters, this Km is equals to K minus 1 plus K2 divided by K1. Okay, so K minus 1 means this equation is enzyme plus substrate is converting into the product. So enzyme plus substrate giving the enzyme substrate complex, which is ultimately giving the product. So this enzyme plus substrate giving enzyme substrate complex, and it is a reversible reaction. So in the backward direction, the rate is K minus 1. K2 is the conversion of the enzyme substrate complex into its product, whereas the K1 is the forward kinetic K on for the enzyme plus the substrate to form the enzyme substrate complex. Now if we want to look into what is Kcat, kcat is also known as the turnover number. So the constant kcat, which unit is second inverse, is also called the turnover number because under saturating substrate conditions, it represents the number of substrate molecules converted to product in a given unit of time on a single enzyme molecule. What it states is that under the saturating substrate conditions, means when this substrate is getting saturated in this position, if you see the graph, that the substrate is now getting saturating. So here the rate of formation and the rate of breakdown of this enzyme substrate complex is equal. So there the under saturating conditions, it represents the number of substrate molecules converted to product. So how many number of substrate molecules are converting to product under a saturating condition, where that is calculating it in a per unit time on a single enzyme molecule. A single enzyme molecule in per unit time, how many substrate molecules are getting converted into product in under a saturating condition, that value is given by this turnover number. And in practice, the kcat values, not the Vmax, are most often used for comparing the catalytic efficiencies of related enzyme classes or among different mutant forms of an enzyme. So here we came across another term which is known as the catalytic efficiency. So this catalytic efficiency in some terms is also called as the specificity of the enzyme. So this catalytic efficiency is simply given by this formula, that is kcat, that is this turnover number divided by the Km, that is the Michaelis-Menten constant, that is this Km value. Okay, so in our question what is being asked is to find out the specificity, and if you see that they have given already the kcat value and the km value, and we need to only find the specificity, then arrange them accordingly into the decreasing order. So now the question is simple. So if we see that what is given here, fluoroformate, fumarate and chloroformate, all these values, Km values are given and Kcat value is given. Only what you need to do is that you need to know that specificity is equals to Kcat by Km. Now divide 2700 divided by 27. Similarly do it for fumarate and chlorofumarate, and you will find these values. Now which one has the highest value? The highest value is having the fumarate. So that's why the decreasing order will be fumarate, then fluoroform fumarate, and then the chlorofumarate. So the answer here will be C. So if you consider that value, then this answer here where is will be C. Okay. Now for your reference, I have given you two courses that you can look into while going through the biochemistry and metabolism preparation for your GATE exam. So the two courses here is by Dr. Shagota Dasgupta of IIT Kharagpur. So the course name is biochemistry. So this is a very good course for going through your basics of biochemistry and the metabolism part. Also, there is another course by Professor Subramanian K of IIT Madras, and you can also go through this course to have a basic idea about this topic of biochemistry and metabolism.